Hi, this is Alex from devstories.eu. LangGraph, episode 7 of 18. Hard-coded conditionals only go so far when you are building an agent. If a user asks a complex question, a simple keyword search cannot reliably decide what your application should do next. What if the AI itself could dictate the path of your workflow? This is where dynamic routing and conditional edges come in. In a standard graph setup, you connect node A to node B. It is a static, guaranteed path. But when you are building an intelligent routing mechanism, the path needs to change based on the incoming data. You might assume that edges in LangGraph only accept hard-coded string connections. That is not the case. An edge can be a Python function that reads the current state of your graph and dynamically computes the name of the next node. You attach this logic to your graph using the addConditionalEdges method. This method requires three components. First, the starting node. Second, a routing function. Third, a dictionary that maps the possible string outputs of your routing function to the actual destination nodes in your graph. Here is the key insight. The most reliable way to drive a conditional edge is to combine it with a large language model generating structured data. You do not want the routing function itself to perform complex evaluation or natural language processing. Instead, you have an upstream node where the model is forced to return a strict structure, like a pydantic model. Consider a customer service router. A user sends a message. The first node in your graph is an intent classifier. Inside this node, you pass the user message to a language model and require it to return a structured output with a single field called intent. The model evaluates the text and populates that field with a specific value, such as billing, tech support, or sales. This structured response is then saved to the graph state. Now the conditional edge takes over. The edge is attached to the classifier node. When the classifier node finishes, the conditional edge triggers a short Python function. This function takes the graph state as its input, looks inside the state, and extracts the intent value the model just generated. If the intent is billing, the function returns the string billing. The conditional edge looks at its mapping dictionary, sees that the string billing corresponds to your billing node, and hands execution over to that specific node. If the intent is tech support, it returns a different string, routing the flow to the tech support node. You are using the language model for its reasoning capabilities to categorize the input, but you are keeping the actual routing logic deterministic. The Python function in the conditional edge is just reading a variable and returning a string. It is highly predictable and easy to test. The single most useful takeaway here is that you should always decouple the decision from the direction. Let the language model decide the intent and write it to the state. Then use a pure Python conditional edge to read that state and steer the graph. Before we wrap up, if you find these episodes useful and want to help support the show, you can search for devstories.eu on Patreon. It really helps us out. That's all for this one. Thanks for listening and keep building.